Anyways, welcome. Good to have everybody here, and I'm sure there'll be others coming on in just a bit. Nice to see you all online as well. Hope everyone's well and safe. Good to see you. And anyways, just any good news happening lately? Everyone's safe. Everyone's healthy. Everyone's good. Yes. I just want to ask, show of hands, how many are able to do the hybrid or are being asked to come back into work completely?
Which one?
Well, let's go hybrid. How about fully back into the office? Anybody there? What about, doesn't matter, you can do whatever you want? Yeah. I was reading about the Apple, Google, kind of interesting. I wonder if that'll be more of those companies that are going to have to make some adjustments. But I think the big thing is going to be salaries, right? If people want to be wherever they want to be, then people less. Anyways, that's good. I'm glad that everyone has an option. So, but it's nice to have an option to be able to come and meet up in person. It's always great to have you. Let's see. I'm trying to think if there's anything else. Plenty of food afterwards. Of course, mingle. I've talked to Lukas, and thank you, Lukas, also for being here, and we'll turn the time to you in just a second, but I've already talked to him about recording, and also about if there are questions during the presentation, just either raise your hand if he can't hear you, or just, whatever, but that's okay, and then of course we'll have the Q&A afterwards, so. And Rich is also on here with Loft. He works with Lukas and has helped to organize this as well, so thank you as well.
Yeah, thanks for having us, Paul.
And with that, I'll turn it on over to you guys.
Awesome. Yeah, thank you so much for the quick introduction. Let me share my screen to kind of dive in a little bit.
Get that sidebar off.
All right. You can see my screen, right?
Yes.
Okay, perfect. Yeah. Hey, I'm Lukas from Loft, and I'm going to talk a little bit about Kubernetes multi-tenancy with you today. I really want to keep this conversational and encourage you to ask questions, throughout the presentation, whenever you want to dive into anything, whenever you think I'm saying, anything that's wrong or where you had a different experience. Happy to, discuss anything you've experienced as well. A little bit about my background. I'm the CEO of Loft Labs, Inc. We're, the classical venture-backed tech startup based in San Francisco. You can probably hear my funny accent though. So I'm originally from Germany, and I work on a whole bunch of different projects in the Kubernetes space. Started out with Devspace, which is an open source developer tool for Kubernetes, and then over Kiosk, a multi-tenancy extension, vCluster for virtual Kubernetes clusters, JS Policy, being a policy agent, and then Loft as the commercial product that we're working on. Just to give you a little bit about background about this talk. This talk is essentially intended for folks that are would probably identify as platform engineers, potentially SREs, depending on what company you work for. But essentially, it's about Kubernetes experts who are already managing Kubernetes clusters and who want to share Kubernetes clusters for several people or groups of people within the organization. So we're essentially talking about soft multi-tenancy. How does that differentiate, hard multi-tenancy, soft multi-tenancy? So I see it that way. Hard multi-tenancy is essentially zero trust between tenants. So there could be multiple users from, different organizations that are essentially sharing clusters, right? So essentially, if you're looking at AWS, right, and their VMs, their virtual machines, this is hard multi-tenancy, right? There's a lot of different customers, and these virtual machines need to be isolated because, obviously, I shouldn't be able to somehow in any way share data with a different organization. Soft multi-tenancy, in my view, is more, being part of the same organization or of a, trusted unit So there's a very small chance of a malicious actor that actually, you know, from the outside wants to attack the system. It's really more about preventing accidents, ensuring stability, rather than, you know, hardening for outside attacks. We assume that, you know, inside actors are usually good folks that are not trying to harm our system. When we're talking about giving a large number of engineers access to Kubernetes, that is actually pretty hard. And there's a variety of challenges involved. And platform teams, in particular, kind of sitting in between, you know, IT and engineering organization, typically have to address all of these challenges, and they're very conflicting requirements. So if you're looking at, you know, self-service and cost, for example, if you're doing a very great job in terms of self-service, your engineers will spin up a lot of workloads, deploy a lot of stuff. So that's very expensive, right? Those two things are essentially, you know, fighting for each other, right? And then there's user experience and security, right? If you're restricting your users very hard in terms of security, that may hurt user experience. If you have a great user experience with no limits for the user, obviously that's a security issue. So we're having these, you know, different forces where you kind of need to balance them out. And for each one of these things, there's also the decision, hey, do we build this ourselves or do we buy it? And with buy, I also mean like buy into an open source project, for example. So not necessarily, you know, going with a commercial product. Just as an overview for what we're doing and why this is kind of in the space that I've been working in for the past couple of years. Essentially, we're working on Loft, which are a commercial product, and we have 4 different open source projects. And throughout the presentation, you'll essentially get to know each one of them because, you know, I'm kind of using them as examples in different stages. So typically, so I gave this presentation at KubeCon last year, and for this, you know, for this meetup, I extended it a little bit because we have slightly more time than I had about a year ago. What we're trying to do with our commercial product is essentially offer out-of-the-box solution for Kubernetes multi-tenancy and self-service. So we essentially help companies, typically like Fortune 500 companies, to, you know, scale up their Kubernetes use from, you know, 50 to 5,000 engineers, right? So typically, you start out with Kubernetes in a way that your, you know, sysadmins get access, your DevOps folks, I guess, and is sometimes the role that maintain your CI/CD pipelines may get access to Kubernetes, but a large part of your organization, your 2,000 plus engineers, typically don't get access. And with Loft, we kind of want to change that and help you go that way. So we, you know, provide Loft as a highly customizable modular solution, build everything on top of Kubernetes, everything is a CRD, and it really adapts to existing tooling and tries to address all of these challenges. In this talk, I'm not going to sell you Loft. I'm just going to show you how you can build your own Loft with open source tooling that's available either from us or, you know, from the rest of the CNCF ecosystem. In general, if someone deploys Loft, you know, they essentially connect different Kubernetes clusters. And then the goal that each one of our users has is essentially to use Loft as an API server gateway. There's no, you know, separate database or anything. Everything is proxied through Loft to these, you know, connected Kubernetes clusters. So you can make, you know, 5 different clusters from AWS or GCP available to your engineers. And this is kind of what the experience should look like and what we're kind of walking towards when going through this talk. Essentially, it's about self-service namespace creation, and that can happen via, you know, a CLI, UI, with GitOps, or with just kubectl. In Loft, we're providing a pretty simple CLI for that. So if an engineer needs a Kubernetes namespace, they essentially run the command loft create space. They provide a name, and then they, you know, the CLI asks them, hey, which cluster of those 5 clusters that you currently have access to, do you want to create this namespace in? But there's more under the hood. So this CLI is not some kind of proprietary, you know, API It is essentially a Kubernetes API. You could also run a kubectl command against Loft, and it would essentially, if you're sending this CRD, it would essentially create a namespace for you. That means you could also, again, apply this as a file, run kubectl apply a new space, and then you would get the same result. Obviously, people can build UIs on top of that. We did that with Loft, of course, so that it becomes easier to manage these CRDs and for engineers to access the system. But let's get back to my learnings about building the system and how, the different projects that you could be using to build something like Loft internally for yourself. So essentially, the first learning that I've seen across all companies that we've worked with is essentially that you should centralize user management and authentication, because it's good to have a single source of truth for everything that's related to user management, because you already have your users and teams in some kind of third-party system, whether that's Active Directory and you can talk via LDAP, or if you have OpenID Connect, to talk to Google or Microsoft. If you're using GitHub or GitLab, there's some kind of system where you already have your users defined, right? And you should try to leverage that system and set up something like single sign-on. There's a really great project called Dex out there, which is a CNCF samples project, which essentially lets you connect to all these different authentication providers and makes it pretty straightforward to set up authentication with any kind of third-party system for Kubernetes. And when you're working with a system like that, I think one thing that is pretty important to design right from the start is not to make the assumption one user is just going to need one cluster, because there are cases where you have failover scenarios, right? A cluster goes down, you're upgrading a cluster, there are certain issues with a cluster. If you have a self-service system in place, it should be pretty straightforward to shift your user to a different cluster. But somehow your authentication gateway and your user management needs to be not in that cluster that you're taking offline, right? That's essentially what I'm trying to say here. So keeping those things in mind is pretty important. And when you want to go a step further regarding, this, I guess, access to Kubernetes, authentication with Kubernetes, one thing that we found pretty important is actually how users retrieve the kube context and how they manage the kube context if they, interact with these clusters. Because typically, most engineers, don't get me wrong, kubectl is not a great development tool, right? But there are a lot of cases where engineers want to dive a little deeper, and they should have the possibility to do that. So getting that access is pretty important when you're setting up such a self-service system. And if you have some kind of, minimal CLI tool, or even just after the single sign-on flow, you have a site where, they can download a kube config in the most trivial case, right? That helps a lot to set up, authentication in the right way. The next learning is essentially restricting users, but with smart default, because UX really matters. So if you're setting up, standard things like network policies or resource quotas, keep that in mind, right? Network policies, for example, a lot of folks recommend deny all policy as kind of the default, which makes sense. And then you want to gradually open it up, but you don't want to open it up too late, right? You want to open it up for your users in a way that lets them interact with the system where they're not immediately having to open a ticket and, essentially reducing friction at that point, right? So you open up traffic within the namespaces your users require. Internet traffic is a big topic. Obviously, we're working with some customers that are in air-gapped data centers. Obviously, that is not an option for them. But in most cases, opening up to, common APIs that are required, and then making sure that, cluster internal DNS works, or, even outside DNS if you provide access to the internet, it tends to be pretty important, obviously. Resource quotas is a good example for having these smart defaults. So typically, what we've seen companies do in the beginning is essentially, enforce resource quotas without setting limit ranges to enforce defaults. That means they essentially force all users, to set limits. Otherwise, they will always hit the quota, or they will always be denied if you don't set any defaults in your limit range, right? Which is pretty unfortunate for users and pretty hard to figure out. So if you're setting defaults and limit ranges, you're essentially setting up a mutating admission controller, which adds these values. And if you set some kind of smart default here, your users should be able to work without having to worry about these things, at least not in the first step. Dynamic admission controls in general are pretty important. So you probably want to prevent accidents where people, consume each other's host names, right? So you want to do some kind of host name validation for ingress resources, for example, where you prevent, that several people try to use the same host name, or where you block certain annotations that users shouldn't be using because they would provision a load balancer in AWS, right? And that tends to be expensive if, 5,000 engineers do that. They all consume an IP4 address or something like that, right? All of these things is typically what you can prevent with dynamic admission control in a very simple way. Open Policy Agent, as a graduated CNCF project, really can help you with that. We recently started a new project called JS Policy. We haven't really talked about it much yet publicly, but you can find it on jspolicy.com. It's already live, and it's already working, and users are already playing around with it, although it's super early. We just launched a couple of weeks ago, and again, we haven't even made any kind of announcement or talks about it. But the idea of JS Policy is essentially moving policies away from Rego, which is the language that Open Policy Agent is currently using, towards something that is more understandable for the users that are being limited by these policies, and also easier to maintain in the long run. So we're essentially betting on the JavaScript TypeScript ecosystem to kind of make the make use of everything that you can find in NPM. So essentially, we're addressing this lowest layer in this pyramid, access control. And we're using Google's V8 engine to run JavaScript code in a container to validate, mutate, or write controller policies. And controller policies is actually something new. They're reactive policies. Think of it like this way: if you want to add so if you let users create namespaces in whichever way possible, you typically want to have a network policy or resource quota in each namespace. You can't really enforce that with admission control, so you're kind of, the only option for you is essentially create a CRD and write a controller, which is pretty rough. It's hard to maintain that. There's a lot of things to watch out when you're building controllers. It can really impact essentially, if your controller is not working as intended, it can essentially, slow down or bring down your cluster, which is not great. What you can do with JS Policy is define certain reactive things, right? So you can say, listen to events that say create namespaces, right? And then after namespaces are being created, then execute this JavaScript code, and that JavaScript code could add, network policies, etc., to that namespace object that has been created and that actually, caused this event. It's a pretty interesting concept, and you're probably going to hear more about it in the future, but it's pretty young. And then the next learning is essentially about automating everything. Dynamic admission control is actually already one step in that direction, but it goes beyond that. If you're thinking about setting up RBAC for your users and enforcing certain labels and annotations, you can do that with a dynamic admission control. But it goes beyond that because you need, some kind of system where your tenants, where you provide self-service for your tenants. Because, if you're creating namespaces for your users, you want to make it as frictionless as possible. You want to focus on the user experience, and you want to reduce the time that it takes to provision those environments, no matter what they're used for, right? Some folks in the organization may be using or maybe creating, machine learning algorithms. Others will run integration tests there, right? But the less friction and the less time it requires to, create namespaces and shared clusters, the higher the adoption will be of the system, of that platform that you're building. So there may be the need to, implement easy approval flows, but wherever that's not necessary, try to automate as much as possible. And even in the approval flow, try to use something like based on Git pull requests or things like that. And then, on top of that, it's often important to also maintain these lower level cluster-wide shared services like, ingress controller, cert manager, etc. There's a certain limit to that. Typically, there is a lot of, conflict of interest, or not a conflict of interest, but conflicting interests, let's call it like that, between what the platform team wants and what application teams want. Application-focused engineers typically want that the platform teams provisions as much as possible for them and takes responsibility for running these things. Obviously, the platform team typically tends to not want to have, that much responsibility in the application space. So you may not want to be responsible for running, 20 different versions of a certain database for all your different application teams. So it makes sense to kind of draw the line somewhere, right? And things that are pretty close to your cluster infrastructure, like ingress controller that actually consumes, potentially a load balancer, IP, things like that, should typically respond more of the responsibility of the platform team rather than the actual application engineers. We actually open sourced a project called Kiosk. You can find it on kiosk.sh, which addresses this multi-tenancy challenge. It is a multi-tenancy extension for Kubernetes, and it's a security best practice that AWS recommends to install in your clusters if you want to introduce basic multi-tenancy constructs. So typically the way that Kiosk works is it introduces a couple of CRDs, and you can see them here in this diagram. So for example, one CRD that we're introducing here is account. An account essentially specifies, a certain subject in a cluster. So if you're thinking about, DEX beforehand, right? You do authentication, and then the user has a subject and certain groups that they're part of. An account selects these groups or subjects, in a similar way as a cluster role binding would do, right? So it essentially selects whatever group or subject you want to provide self-service access to, and then in that account you specify things like how many namespaces can be created under this account, and then there's a resource called account quota, which is an aggregated resource quota. So if you're thinking about resource quotas, they typically limit, CPU, memory, and things like that per namespace. But, platform teams that manage infrastructure for the engineering organization typically don't care if their user splits something up in 5 namespaces or in 10 namespaces, right? There's a certain limit of namespaces that you typically want to enforce. People shouldn't go over 50 or 100 namespaces. But typically, it doesn't matter if someone has 1 or 2 namespaces, as long as the aggregated amount of CPU is not more than 10 cores, or the memory is not more than 20 gigabytes. Account quotas let you do exactly that. They're resource quotas, but they're aggregated across all namespaces that belong to a certain account. And an account has so-called spaces, and spaces, that is actually kind of a special kind of CRD, because it's not persisted, is a virtual resource that abstracts namespaces. The reason why we introduced space is if you're in a multi-tenant cluster and you want to allow users to, list their own namespaces, create namespaces, also delete them, you typically can't give them permission directly on the namespace because, with Kubernetes RBAC, it's either all or nothing when it comes to listing, for example. I can either list all namespaces or I can't list any namespaces. But typically you want users to see the namespaces that they have RBAC permissions within to do something in these namespaces, right? So if I have 10 namespaces in total and I only have RBAC permissions to deploy, pods, etc. in 3 of these 10 namespaces, then it would be kind of nice if I'm able to list these 3 namespaces, potentially even set annotations, potentially even have the permission to delete them. And those things are essentially handled via spaces. So what spaces do is an API server extension, and it essentially queries namespaces under the hood. So if you run kubectl get space, you're going to see a list of namespaces, but filtered for only the namespace that you have RBAC to. That's why we're using an API server extension here, essentially. But they're not persisted. And then another CRD we're introducing is so-called templates. And templates let you add these security constraints and automate the instantiation of those security constraints. So what we were talking about earlier in terms of network policies or resource quotas or other objects that you want to, create in a certain namespace, whenever that namespace is created, that can be handled with so-called templates. So in a space or in its account, you can essentially enforce these templates, and then they're being instantiated inside the namespace. And Kiosk sets up RBAC in a way that you can't manipulate the template instances. So any kind of resource that is being created cannot be deleted, or if it is deleted, for some reason, it will be recreated. So Kiosk keeps those resources in sync to make sure that at all times your security constraints are enforced. Yeah, so that's an overview of Kiosk as a multi-tenancy extension. The learning number 4 is essentially use GitHubs where it makes sense. It's kind of interesting. I mean, there has been a lot of use of GitHubs as a trending buzzword, and it's great to store things in Git. You get your free history and audit log via your commits. You can do easy rollbacks. You have an built-in approval process via pull request. You can use code owners files. All of these things are really great. I just want to point out that there are cases where it really makes sense to use GitOps. Everything that your platform state encompasses, right? So your platform state is really, for example, your Kiosk deployment, your Dex deployment, how these things are configured, right? That should be treated as a production system. That should be seen as critical and persisted, right? And essentially, that is stuff that your infra team or your platform team manages. And it includes all these security templates, tenant limits. All of that configuration should definitely live in Git or in some place that you can version it, roll back quickly, reproduce that state in a different cluster. That is really great. But there are certain limits to GitOps. Essentially, when it comes to a lot of these ephemeral pre-production topics, GitOps can be really harmful for the developer experience. So if your engineers always have to commit everything to Git and always go through that additional pipeline and don't have a direct access to Kubernetes, that can be very harmful. A classical example is essentially, you have your CI/CD pipeline that manages all the user's access to. That's essentially an intermediary between the user and the Kubernetes cluster. So what happens if something goes wrong? If a user needs to dig deeper into what Kubernetes is doing, these certain events, certain logs may not be exposed to the user, and that often is a problem. And then one thing I always tend to remind people of when it comes to that discussion is, do you really need these benefits that we listed above there? Do you need the history? Do you need the audit log for a pre-production environment that a user has created to test something in Kubernetes? Do you really need, the history of a review app that has been created by your CI/CD environment? Potentially not, right? There may be cases where you need it, but it's probably, it's a case-by-case decision, and it should definitely be considered, because I've seen a lot of, companies fall in this GitOps trap and say like everything needs to be, right? And I think there's a certain limit to that, and it really depends on the certain use case. In Kiosk, you essentially have these different resources like account quotas, space, template, etc. And that makes it pretty easy to, version that in Git. But the question is, do you really need, pods, for example, that run in a namespace that has been created with Kiosk? Potentially, potentially not. Learning number 5 is monitor cost and track down idle workloads, and that's a pretty important one when it comes to scale within the organization. Essentially, what you always want to enable is cluster auto-scaling if possible, right? If you're in AWS or in GCP, that's just a click, right? But enforcing application auto-scaling is a lot harder. But you still need to worry about essentially scaling up and down your applications, or you're tracking down your idle workloads. Because if you're doing a great job with your platform, then your application engineers will be very quick to spin up and deploy a lot of things, right? That's essentially what that platform is meant for, right? You did a great job in terms of user experience, and they make use of that. But engineers tend to be very terrible at turning things off. I mean, not just engineers, everybody pretty much is pretty terrible at cleaning up after themselves. And it takes a lot of enforcement to do that. So essentially, a much better solution is to automate certain shutdown procedures to track cost. One of the tools, a couple of the tools I listed here are pretty useful. So cluster turn down, for example, is a tool by Kubectl. Kubectl itself is a very useful tool to monitor cost in your Kubernetes clusters. Cluster turndown is a tool that they created, to essentially shut off certain things in your cluster at a fixed schedule, right? So you kind of have like hey, at 10 p.m. in the evening, probably people are not working on this thing anymore, so let's turn that off. Then you have things like ingress-based, network traffic analysis, like OpenShift does it. They have a feature called idling, which essentially hooks into your network traffic and sees like, hey, is there any network traffic going to this object? If not, right, we can essentially turn that off. And then in Loft, we have a feature called sleep mode. It's similar to what OpenShift does, but with the difference that we're really looking at who's working with which Kubernetes cluster. And then we see, hey, you've not been running any commands in this namespace for the past hour or whatever the admin enforces. We can turn that namespace off. And putting it to sleep, turning it off essentially means we're setting the replica number of all your deployments, replica sets, etc. to 0. That means Kubernetes is going to purge all these pods, but the configuration is still there. We annotate the original replica number as an annotation on the respective object, so that state is preserved as well. And then as soon as the first kubectl request comes in, again, since we're kind of in the middle between the user and the Kubernetes cluster as an API proxy, we halt that request for a second. We restore in that particular namespace that the user is now using. We restore, so we're essentially analyzing the Kubernetes API server request. We see, hey, it goes to that namespace is currently sleeping. We see that with an annotation. And then we restore the replica number, halt that request for 2 seconds or so, let that request go through, and all the pods are starting again. So the user essentially doesn't need to turn anything off, doesn't need to turn everything on again when they start working. And you save cost essentially the entire time while the engineer is not working, right? That means like when they're asleep on the weekends, etc. You know, if an engineer works 40 hours per week, right? 24 times 7 is the hours per week. That's a lot more than 40 hours, right? You can save essentially over 70% of infrastructure costs with this, and it's pretty easy to build that. You know, to either use it out of the box as part of Loft or to build it yourself. The algorithm I was just describing is pretty straightforward, right? And then the last, this is the second last learning. The second last learning is essentially sometimes users need more than just a namespace. Typically, when we're talking about multi-tenancy in Kubernetes, we're talking about namespace-based multi-tenancy. That means, you know, we're sharing clusters based on namespaces or groups of namespaces. You know, the tenant may also have 5 different namespaces and work across these namespaces if your network policies allow that. But what if a user needs to install a CRD? What if they need an helm chart which sets up RBAC or you know, install CRDs? What if they need to enable Kubernetes beta flag in the API server or the controller manager? What if you know, that need a different Kubernetes version than the underlying cluster? Well, all of these things can't be solved by namespaces because we're not giving the user access to control the entire cluster, because that would be chaos. So that can't be solved by namespace-based multi-tenancy. And that's why we started a project that's also open source called vCluster. vCluster lets you create virtual Kubernetes clusters that run inside the namespaces of other Kubernetes clusters. That means users can provision these virtual clusters themselves inside their restricted namespaces. And then inside that virtual cluster, it has a separate API server, it has a separate controller manager, it has a separate data store. Typically, we use SQLite instead of etcd, but you can also use etcd or, you know, MySQL or anything else that K3s supports, because K3s is used as the API server component in vCluster. The admin of that virtual cluster, not the admin of the underlying cluster, the admin of the virtual cluster, which is the regular engineer, has now unlimited access inside of there, right? You can change the K3s version, get new, you know, Kubernetes features in, change an alpha, enable an alpha feature. You can, you know, set up your own RBAC, network policies, install CRDs, work on controllers. There's a lot of freedom that you have in a virtual cluster. And everybody gets their own Kubernetes control plane, which offers even better isolation than namespace-based multi-tenancy. And it's still possible to share, you know, certain resources in the underlying cluster, like, for example, the ingress controller. But that's a pretty detailed topic. It's a pretty exciting project. We launched it about, you know, 3 or 4 months ago. And about 4 weeks ago, it became a certified Kubernetes distribution, which was definitely a really big step for the project. So if you're interested, feel free to check it out. It's on vcluster.com. And again, it's open source. It comes as part of Loft. That's kind of, you know, we built it in Loft first, but then we saw so many different use cases for it, and so many folks were interested in asking about it that we're like, hey, this needs to be open source, and ultimately we want to contribute it to CNCF, which we're pretty much on track with, considering, you know, that it's a certified distribution now, and people seem to really love it and engage with the project. If you're looking at the comparison and at this pyramid, typically vCluster addresses a whole bunch of these challenges, right? It improves the developer experience because you get access to your full Kubernetes cluster where you feel like you're completely admin and no limits, essentially. It addresses, you know, the cost aspect of things because it prevents you from creating very expensive, you know, multiple Kubernetes clusters for your engineers. They just keep using their namespaces. And if you have something like sleep mode or cluster turn down, sorry, enabled, then you can also turn an entire vCluster off, which is pretty interesting, right? So instead of turning off a namespace and putting that to sleep, you're still putting the namespace to sleep, but the virtual cluster runs as a pod inside the namespace, so it goes to sleep as well. So it's pretty cost efficient. And in terms of self-service, well, we designed vCluster to be deployed in a very restricted environment. So whether you're creating your namespaces, with OpenShift or Rancher or Loft or any of the other solutions, and you only have RBAC permissions to do something in a specific namespace, you'll still be able to use vCluster. You essentially run helm install to deploy a vCluster, or you can also use our CLI to make it even easier. vCluster create, to create a vCluster, or you could just run kubectl apply. But all that a vCluster is it requires a persistent volume that is attached to a stateful set, and it has a service, and you do port forwarding to that service to get the connection to the API server. That's it. And then for the workloads that are being created, you need to also be able to create pods in the underlying namespace. So that's all you need in terms of RBAC permissions, and you have a beautiful self-service system that provides full cluster access. Users just need to be able to create persistent volume claims, stateful set, and pod. That's pretty simple, right? And then inside the virtual cluster, when they're connecting, in the simplest case, via port forwarding, in a more complicated case, via ingresses, when they're connected to their virtual cluster and talking to that API server, they can do anything. And in the underlying cluster, typically it will only create pods. And then obviously that's pretty good for tenant isolation as well, because everybody talks to their own API server, and only very few requests actually reach the underlying cluster. So if I create a deployment, a stateful set, etc., to in my virtual cluster, only the pods of those objects will live in the underlying cluster. But the stateful set itself, or anything, any kind of CRD, any kind of admission control that I'm testing, all of that happens inside the virtual cluster. Yeah, this is kind of how that looks like on a architecture basis. So when the user is running a kubectl request and talks to the vCluster control plane, that essentially runs operations inside the vClusters. And again, that is a K3s API server that we're using internally inside vCluster. And then inside that virtual cluster, as you can see it on the top here, you can have different namespaces, and you have a kube system namespace, which you can also access, which is going to show you that K3s API server. It's going to show you a core DNS pod, and it's going to show you a so-called syncer. And the syncer component, that's kind of the magic in this case, because what the syncer does, it synchronizes basic low-level resources like pods and services to the underlying host cluster. You wouldn't even need services if you don't want to do, pod to service network connection. But what the syncer does, it rewrites the names of these pods to make sure that they're unique, right? So for namespace NS1 and pod 1, the resulting name in this host namespace, where all the pods end up, no matter in which namespace they are inside the vCluster, they get rewritten like this: pod name X and then namespace name, to essentially make sure that they're not colliding, right? There's two pods called pod 1 in two different namespaces, but in the underlying cluster, these pods get started in the same namespace. So we actually need to rename them in the process. And then the virtual cluster has its own API server, its own data store, in this case by default SQLite, but again, you can swap it out to anything else. And it has a controller manager, which controls like the deployment, stateful sets, etc., and would create the pods for you inside that data store. The only thing that the virtual cluster does not have is a scheduler. And instead of the scheduler, it has a syncer, which just synchronizes resources down to the underlying cluster, and then it synchronizes the status of resources up to the vCluster again, so that the user can, while still being in a virtual cluster and talking to the API server of the virtual cluster, the user can still see, is a pod running, is there image pull back off, are there any kind of admission control restrictions or anything that is, hindering that pod from actually starting, volumes cannot be mounted, etc. All of that is very transparent for the user, which is tends to be a good experience. And last but not least, is the last learning. When you actually, going through all that process and making Kubernetes available to your engineers, you're doing a good job in terms of cost management. Adoption is high, self-service is working great. Then do not hide Kubernetes, but make it easier instead. So typically, and I mentioned it before, engineers want direct access to Kubernetes, because if they don't get it, there's a lot of back and forth between platform teams and engineering teams about access to certain resources, access to logs and events, and there's just a lot of friction if you can't just quickly run a kubectl command that you found in a tutorial to debug a certain issue with your application. Because as an application engineer, that's your job, right? It's not necessarily your job to debug the cluster, but if your image is failing because a certain file cannot be read or something like that, right? It's probably within your scope and not in the scope of the platform team. So essentially, if they want to verify new features, instead of going through the entire CI/CD circle and running your 5,000 integration tests, engineers can change a single line of code and then run targeted like 2 or 3 integration tests to see, hey, does this new feature impact these integration tests that I suspect it would, right? Before they're pushing things to Git to kick off the full CI/CD, quality assurance, etc. And then, again, to debug container startup, to inspect the state of the application, to even attach a debugger and trace requests between your microservices. Very useful for engineers to directly be able to access Kubernetes. But again, kubectl is an API client. It's merely, a wrapper on top of API HTTP requests, right? That's all it is, essentially. It's not a fully fledged developer tool. So my recommendation would be leave developer tooling and deployment workflows to the engineering teams, but raise awareness for any of the 50 plus open source developer tools for Kubernetes. There's Scaffold, that previously was Draft, that has been discontinued as the 2 first projects in the space. Devspace is a project that we kicked off in 2018. Tilt is another great project. Telepresence is a CNCF sandbox project. There's a lot of great projects that make life with Kubernetes easier. If we're looking at our pyramid again, they essentially address, I would say, the top 2 layers: developer experience and collaboration in a certain way, because all of them typically tend to have a configuration file that is maintained within the application code. So in a way, you're sharing best practices and you're sharing this, build and deployment and hot reloading workflow with your colleagues by maintaining that file in your Git repository together with the actual application code. With Devspace, we're trying to be a Docker Compose and a drop-in replacement for Docker Compose, but for Kubernetes. So essentially, it's a client-only CLI tool. It's, again, open source. It uses your current kube context, so whether that's a Minikube cluster or a cluster that's connected to Loft, or your AWS cluster that you have full root admin access to, or a virtual cluster. It doesn't matter as long as it's a valid kube context. It can work with this cluster the same way as kubectl Helm would do it. And Devspace is client only. It requires no server-side component, just like most of these other tools I've shown you. And it is able to work with very restricted permissions. So typically in this namespace scoped world, that works very well with Devspace, or again, any of the other tools. Devspace also provides a client-only web UI. So when the Devspace dev command is running, developers can actually access a localhost address in the browser to access this web UI to kind of inspect, which pods are running, why are they failing, what can I do about there. They can also exec, run kubectl exec by click of a button and do that right in the browser if they want to, inspect, a certain volume that has been mounted or things like that. But typically the pipeline for Devspace works like this. The developer has this local file system with the, with their application code and with their Devspace YAML file, this configuration file. And then they use the CLI to run the command devspace dev, which runs a local pipeline to potentially build images. In some cases, that can be skipped, to deploy the application via Helm, kubectl, customize, etc. And then the application is running inside a Kubernetes namespace, and devspace dev stays open as a command and starts port forwarding. That means the engineer can now access, services that have been deployed on localhost, which is great, just as if they would run kubectl port forward, right? But you can, run 8 port forwardings in parallel, essentially. And then a very cool thing about this is also the file synchronization, which essentially does hot reloading. So if you have a hot reloader in your application, or if you configure devspace dev to open a terminal and not start your application, you can tell it, hey, don't start a particular container. So essentially start it with a sleep command instead of the actual entry point, and let me exec into that container. Then you have a terminal and you can start your application yourself. And when you change a file with your local IDE, this file sync will synchronize it to the container file system, no matter if that's on a persistent volume or in an ephemeral storage. We would overwrite that file, and then you can either use a hot reloader, which detects that file change and reloads the application, or you could just abort the command in your terminal and rerun it. That way you get a very efficient workflow for your engineers, where they don't need to, build images over and over again, tag them, push them, reinstantiate them in Kubernetes. It's much faster to do this hot reloading workflow where you actually swap out files and build or rebuild, your Go binary or your jar file directly inside the running containers. Obviously, that requires sometimes to not use the production image, which is probably hardened and doesn't ship with the developer tooling needed to actually build the application. But that's usually not a big deal, right? You just tell Devspace, hey, instead of using this image, please swap it out with this image. Devspace can make these changes on the fly. And yeah, that's the end of the presentation. I went through all the learnings that I've gathered over the past 3 years that we've been building this company and working in this space, and of course a variety of different companies that we've had the pleasure to be working with. And if you have any questions, I'm very happy to answer them.
So I had a quick question, Lukas, on your vCluster. It sounds like, if I understand correctly, when I looked at it before, it was go back to that architecture. The actual pods and resources are in the host namespace or the host cluster. So how does things like, if you wanted to, you mentioned an API server could change because you're using K3S. What about CNI or other things like that? Because I don't see how that would work very well.
Yeah. So typically, with CNI is actually pretty interesting. I actually was. That's one of the 2 questions that always comes up. That question and the question regarding storage.
Yeah,
and
that's my next one.
Right. Yeah, and actually they're very smart questions. So it's always good when those questions come up. I know that the audience got what I was talking about, right? It's great. So essentially, that is difficult. So you can have different storage providers, and you can have different CNIs in your host cluster, and then make them available to your virtual cluster. But obviously, if you don't have a certain storage class in your host cluster, then you can't use them in your vCluster, right? So you can only, there are plugins to Kubernetes where you can support multiple CNIs, right? And the selection is typically done, I think, via labels and things like that, right? And then you can essentially make that available to the user, potentially enforce things with admission control, and restrict the user to a certain CNI or to a certain storage class, but you can't obviously have the user change that within the vCluster, because that's not something that the vCluster does. The vCluster does not schedule any workloads, so it doesn't inherently itself provide any, storage provider or network plugin.
So as far as network policies, help me understand a little bit on your vCluster between, one would use this for a nice, well, let me ask it this way. Would you use this for a multi-tenancy type environment, or would you use Kiosk more for that? Because I'm trying to understand, the isolation here is still not exactly.
This seems to me more based around API isolation. It's about what you can and can't do with the API server, not about what the workloads.
Yeah, so I'm just trying to make sure in my mind where I kind of have multi-tenancy versus this world.
Yeah, so the way I see it is to me, there's essentially 3 layers. And we've been talking about the 2 upper layers. At the very bottom layer is actually, things like kernel isolation and stuff like that, where you potentially, that's kind of when we're talking more about hard multi-tenancy, right? Where you want to have things like nodeless Kubernetes, right? Where you provision micro VMs for each pod because you don't trust what is running in the pod and you actually want to pack it in a small VM, right? I think that is the lowest layer. The layer in the middle, and that's what you've been talking about regarding, isolation of what workloads can user schedule and RBAC in the underlying cluster and things like that. That is what Kiosk is addressing. And then vCluster complements that by another layer on top. And that is, to me, vCluster is not restricting your user. It's rather opening things up that have been too much restricted by Kiosk, right? So we make sure with RBAC and Kiosk, network policies, etc., that the user can only stay within that namespace and cannot break out. And then with vCluster, we put a layer on top of that, which undermines exactly that, right? But in a secure way, because everything happens on a virtual layer. It doesn't actually happen in the underlying cluster.
So you'd always use them like in tandem, like together?
Yeah, exactly. Yes. I mean, if you, for example, would skip admission control in your dynamic admission control in your underlying host cluster, and you probably don't want to allow your user to create privileged containers, right? You'd have to enforce it in the underlying cluster. You can enforce it inside the vCluster as well, but I mean, the intention of the vCluster is that your user becomes admin of the vClusters, so they could just remove the admission control, right? And then you would have to do multi-tenancy and add Kiosk again to the vCluster, and then it's kind of an endless loop. So essentially, it makes sense to use admission control, network policies, all these things on the underlying host cluster, and then in the vCluster, leave the entire freedom to the user. That's kind of how we see it being used today.
Yeah, I have some friends who are really big time security nerds, and they were poking at vCluster, and that was the main feedback that I got was, just make sure to do admission control and network policies and all of those things that you would normally want to do anyway at the host cluster level to make sure that there's not a container breakout or something like that.
So in the real world, as far as corporations or entities, are they using vCluster mainly for how do I say it? Almost like a virtual mini cube. It's kind of like a,
that's pretty much it.
It's because Minikube, it's always, I've got to get a 64 gig, Mac, to have things running on it. So this is kind of like having a distributed Minikube for testing, development, experimenting and that type of stuff. Are you seeing other usages other than that in a production world, if you will?
Yeah, we do. So there's a couple of use cases. So again, what you were saying is correct. I think that's a pretty interesting analogy, like the hosted Minikube, I guess, right? Or K3S hosted, right? Yeah, that's pretty much the use case that we started out with, kind of from the background, that we are addressing. That is essentially exactly the use case that we're addressing with the commercial product. That's why we came up with vCluster as a solution to that, users complaining we're too limited with a single namespace, right? Minikube and other local clusters are too hard to run, too many resources are being consumed, they become pets rather than, cattle. They break quickly, and then, platform teams get contacted with, hey, my Minikube cluster's not working, and things like that. vCluster can prevent all these things, right? But yeah, we've been contacted by a lot of companies, and some of our users are already exploring that as well to use vCluster for certain production use cases. One of the use cases is actually, so imagine you have a managed product. And your managed product is already pretty far in terms of, hey, that is a really cloud-native product. So it interacts a lot with Kubernetes. It may store certain things in secrets, right? It may have its own CRDs, right? And you're running your software for customers as a managed service. So ideally, you want to have one Kubernetes cluster where you run 100 instances of your product and sell these 100 instances as a managed product to your customers, right? Each customer gets one instance. Today, that's really hard for a lot of organizations because essentially everything is tied to that one underlying cluster. That is such a critical component, and so many things have to be shared across all these instances, right? If your product has something like a controller baked in, it's just impossible, essentially. And what we allow them to do is to pack their instances of their managed product into a vCluster, and that is much more efficient, obviously, than creating your own or creating separate clusters. But also it provides, this IPA server isolation, DNS isolation, a lot of these like additional layers that actually someone would have to break through, or that have to, go down, etc., to cause any issues. And your underlying host cluster can be really dumb now, which is really great because that's what you want, right? You don't want to have a lot of complexity at the lower level. The same way we see kind of these host clusters essentially as, if they're as minimal as possible, it's great, because that's kind of what happened to VMs as well. We treated VMs like pets before, and now, like, who cares about VMs, right? Your AWS EKS provisions them automatically for you, you don't really think about VMs anymore. And I think the same will happen to Kubernetes clusters. But let me tell you two additional use cases that customers have came up with. One is essentially about scalability of Kubernetes. If you're thinking about a 5,000 node Kubernetes cluster, that API server, that etcd, that scheduler, everything is under very, very high load, right? The controller manager has to manage all these deployments that you're having there, right? If you're scaling a Kubernetes cluster to those limits, that's pretty rough. If you're having vClusters on top of that, 99% of the requests live inside the vCluster, and then the underlying cluster only gets like about 1% of the requests that actually the synchro needs to handle. But all the requests that your CRDs are causing, right? Everything that your controllers is doing and storing in secrets and stuff like that, right? All of that is shielded from the underlying host cluster, so you can actually scale Kubernetes much, much further than you could today. And then another pretty interesting use case is, well, there's actually two more. One is cluster simulation. So say you want to test a new ingress controller and things like that, right? That it becomes very, very easy in vClusters, but again, that's not production use case. And then the last use case that we've discovered so far is, and that's actually not supported yet in vCluster, but it's something we've been thinking about. vClusters backed by different host clusters, because that is something that could technically work as well. So a vCluster could sync these pods to different clusters depending on the properties of the pod, or certain conditions of the underlying clusters, because it totally abstracts from the underlying cluster. But yeah, again, that is not supported yet, and just like something that users have started thinking about, and we're probably looking into this, I don't know, maybe in a year from now. That's pretty far off.
questions. I've got a couple more. Anyone?
Yeah, I had a question. This is Pete. Can you hear me okay?
Go ahead, Pete.
Yeah, so we've been trying to figure out a way to allow developers to do integration testing, essentially in the integration environment without breaking the integration environment for other teams. And I'm curious if any of your tools, I was just thinking about this as you were talking about Devspace, if any of your tools would, the ideal would be that when a developer wants to deploy their service, they could copy the integration environment, just update their service, and then be able to run the full set of system integration tests with all the other services without having to do that full deploy of every microservice. I'm just curious if any of your tools would help with that type of a scenario.
Yeah, definitely. So yeah, Devspace is pretty helpful in that regard. So we have one customer, for example, it's a pretty large like Fortune 50 financial institution. They were essentially using their CI/CD pipeline a lot to run all of these tests, right? Because it's really hard in such an environment where you're not allowed to run Docker locally, right? To test your full integration with 10 other microservices, right? It's pretty rough. By switching to a remote Kubernetes environment, their local machine, which is very shielded and restricted in terms of what they can do, is not as important anymore because it's just a window to your remote environment. You're still using your IDE, right? And you're still using your local terminal. But in the end, your workloads run in Kubernetes, and Devspace does the connection from local to the remote environment by synchronizing files, establishing port forwarding, etc. And it's pretty easy for an organization to monitor these interactions, etc. Because everything goes to the Kubernetes API server, which is great. You get audit logging and all these things. And then when you are talking about spinning up environments, so typically Devspace lets you. So Devspace YAML lives in each Git repository where your source code lives. If you have 30 microservices, we have companies that have like 30 or 40 microservices that they want to stand up together. There's essentially two approaches. One is Devspace allows you to define dependencies across Git repositories. So it would essentially, similar to Helm chart dependencies, right? It would essentially deploy these dependent projects first and then your application. But again, that means like everybody stands up everything. And the other approach, and both of these approaches can be combined depending on, one microservice may, for example, always need a copy of a different microservice because you're working on both of them, together for some reason. But for other things, like for example, everybody needs access to a shared Kafka message queue or some kind of heavyweight application or some authorization service, which has some kind of user data and handles authorization or authentication, and having that as a central service makes sense. And wiring that up in your Kubernetes cluster and allowing, as a platform team, you could essentially maintain a stable version of that service in some namespace, and then allow network traffic from all the users' namespaces to that namespace, right? And then all your engineer needs to do is fire up Devspace, and Devspace uses cluster internal DNS. The application that you're running with Devspace uses cluster internal DNS to connect to that microservice and to 10 other microservices, which are deployed from your stable Git branch rather than, and kind of run a production-like state, and they're maintained by your platform team rather than your application engineers, for example. That is something we've seen before as well, for sure. And then you can still run your integration tests, for that microservice that you're actually working with, but using the others kind of as a staging environment.
Yeah, that sounds really cool. Actually having the flexibility to decide what things make sense to deploy for everyone to use versus what things are deployed into each test environment, that sounds like a really cool idea.
Yeah, I think what we're trying with Devspace is be very, very flexible. If you go to the documentation of Devspace, the tool has been around since 2018, and a couple of thousand organizations have used it. So we've seen a lot of different use cases and requirements. And what we're trying to do is be as flexible as possible to support whatever you want to do with the tool. So be quite unopinionated about it, right? You can configure Devspace to build images, or you can pull images from somewhere that are built via your CI/CD pipeline. You can tag images in X kind of ways. You can have these dependencies or have these stable, dependencies already running that you're connecting to. You can open a terminal, or you can open log streaming at the end of the Devspace dev command, right? There's like literally like 5,000 options. If you're going through the documentation, you'll see that Devspace YAML is a very, very highly configurable file, right? And that's very important because we're trying to be supportive of most of these use cases. And depending on your language, frameworks, and internal policies, there are so many things to consider. And you can even take it a step further with things like hooks in Devspace and plugins. You can write your own plugins for Devspace, so that for example, you can add your custom commands to Devspace, because Devspace is supposed to be like this internal Swiss Army knife, right? That you bake into the developer's workflow. But we know that we can't cover everything because certain things are very company specific. So just write a plugin for Devspace, and it's very easy for a user to install that, and to upgrade it with a single command. So we kind of have that flexibility built in the tool. Not from the start, but over time. Again, it's been out there since 2018, and we've learned a lot and restructured a lot to make it more flexible.
Well, I know what I'm going to be doing the rest of the evening.
Have fun exploring the options of Devspace.
Yeah, thank you. That's very helpful to have that introduction.
Sure.
Any questions? Could you go back to Kiosk for a second, your architecture document, diagram?
That one or this one?
Nope, either one of those. I'm trying to understand a little bit on the actual capabilities of the template and the template resources. Could you expand like its breadth of? What can I template? Anything?
Anything, yeah, that's the answer. So essentially, what you can specify in a template is either manifests, so it has like it's basically a list of manifests that you can pass to it, right? Or you can pass to it a Helm chart with values, either or. And you can also have 5 templates that, so typically we see users don't, companies tend to create templates for specific things, right? So you have a template for a specific network policy, and then you have a different template for another network policy. And then you have 3 different templates for your resource quotas, right? Or for your limit ranges. Typically, you want to have as many templates as possible rather than putting everything in one template. And then for each one of your user accounts, you select which templates should be enforced. So typically, you have think about it, one template contains one Kubernetes manifest. It would theoretically support multiple, but that's what we see most of the time.
And then I just had a question on network policies and space. How does that work? Do you actually have to do? Can you go into a space and have individual network policies for the namespaces, or do you have to do it across the spaces? I don't know if that makes sense.
Yes. Again, so space is not actually something persisted in your cluster. It's just a virtual representation of a namespace. So if you're talking about a space A1 and a space A2, there is a namespace A1 and a namespace A2 for that space. It's a purely virtual abstraction, right? So your namespace...
You still have to do anything you're trying to do from a namespace, like network policies or anything like that.
Exactly.
You still do that at the namespace level. There's not a construct of saying I want to do it across spaces. You're not at that level.
Still do it across.
No. What you would do if you want to enforce a network policy across 5 different user and there are 50,000 namespaces, right? You would have a template and then you would tell Kiosk that it should enforce that template for this particular account, or for those 5 accounts. And then all the spaces that a user creates, which are essentially just namespaces, Kiosk would create the template instance. That's another CRD. It's a namespace CRD that would live in this namespace, and it would essentially create these resources inside, or the controller would create these resources inside of that namespace.
Okay.
So the interesting thing about that is this stays in sync all the time. So if you're updating the template and you're updating your network policy, all the spaces or namespaces that have this template instance will also get this revised network policy, which is pretty cool.
Yeah, that's really cool.
I see that.
That's also a way to kind of, I was talking earlier about things, that you should put in Git and other things that you shouldn't, right? If you have these ephemeral namespaces that your users are playing around with and testing with, right? You don't need to version in your Git repository for your 5,000 user-created namespaces all these network policies, right? What you version is the template that enforces that network policy in these 5,000 namespaces, and the mapping which template should be enforced for which user, and potentially also the spaces themselves, but nothing inside the namespace typically, because Kiosk controller will keep that in sync for you essentially. If you update the template in Git and your GitOps flow updates that in the cluster, then Kiosk sees that change and would update the template instances, which would then update the resources that have been deployed by that template instance.
You see this most generally used, the templating used for kind of policy stuff like we're talking about, network policy and limits and that kind of stuff, or do you see it used like, that makes a lot of sense. My first look at it, I thought, well, it's sort of a like, let me automatically make this service for you. Do you see it used for like supporting services as well, or mostly just for policy?
Yeah, we see it for, so typically we don't see it for heavyweight stuff like actual applications, because again, especially since, we're also the maintainers of Devspace, we kind of believe that standing up your application is a different task than provisioning a namespace, right? So you provision a namespace with something like Kiosk or Loft or create a vCluster, but then how you deploy your application and which services that needs, etc., that should be in your Devspace YAML or Scaffold YAML or whatever tool you're using there. That's a different kind of responsibility and should also be maintained by a different persona, right? That's why we typically see these things more on the security side, platform side, rule enforcement side, rather than application-specific stuff. There are some exceptions regarding, for example, image pull secrets, stuff like that, right? That's not necessarily a security constraint. It's more something that your user may need, or some kind of, we really see it a lot with secrets and config maps, right? Things that you want to pre-populate for your users that they can use in any of the applications, but they tend to be lightweight things, right? Not actual, deployments or workloads. But it's possible as well. It's just not what we typically see.
Okay, yeah. I mean, it sounds like you make any resource. It makes more sense in the kind of the supporting metadata and that kind of stuff. So.
Exactly. Yeah. Yeah, you're right.
Anything else?
You have a question on the V cluster. Sorry, going back to that. How does this? I guess I'm kind of having a hard time understanding how this works in the a real world example. Like a dev team creates a V cluster and they go bananas with creating all these CRDs and operators and things like that. One would be like operationally, like if something goes wrong, do the platform teams typically have to get involved in whatever is going on in that V cluster?
Mm-hmm.
That'd be question one.
Yeah, I mean that's what we're trying to prevent, right? So if you have a self-service system for namespaces and that gives you a self-service system for vCluster, effectively, again, platform teams should not get involved because these vClusters should be treated as cattle, right? If your engineer does something weird with it, something breaks, and they have the state in Git, roll back. If they, just create a new one, purge the other one. It's really just about deleting stateful set and a persistent volume, and that's it, right? Then your vCluster is gone. You can spin up a new one. I mean, it takes like 3 or 4 seconds to spin up a vCluster. if the images are already pulled. Yeah, we typically don't see them debugging V clusters. Another reason for that is also users tend to create separate V clusters for separate things that they want to test, right? So let's say you want to test like a new ingress controller next month or something like that, right? You're creating a new V cluster, and then 3 months later you want to test this machine learning framework. You just create a new V cluster. You typically don't mess around with just one of them, just because it's so easy to create them.
So, and then my second question would be so they have this V cluster set up. They've created some really awesome CRDs. I'm assuming that they have all the access from the host level, from the host cluster in the V cluster. How would they go about sharing these awesome CRDs or whatever they've created with the rest of the dev teams, right? Would it then now have to get installed onto like a host cluster?
Yeah, I mean, that's an interesting question. It kind of depends on what your CRD is doing, right? Are you writing a CRD for your application that runs as a managed service, right? In that case, you probably just, check it in Git, they do QA, and then they push it to production and update the V clusters that run the managed instances of your customers, right? Or is it a CRD and a controller that actually facilitates your it's not application specific, but rather, enforces, like if it's an infra CRD, right? Then it's something different, right? So if you're writing a CRD which abstracts the construct of an ingress, right, with some higher level construct that does other things, right? Then that would typically not be developed by your application teams, but by your platform team. And yeah, I mean, if you need that in your underlying cluster, sure, that would need to be deployed there. But I would argue you deploy it through your, typical CI/CD GitOps workflow, rather than just applying it directly. But yeah, essentially, that's how it would work. One thing that is also interesting regarding this is sharing. So what is possible right now is sharing certain things between a V cluster and the underlying host cluster. So for example, going back to this diagram, this syncer can be configured in a very custom way. By default, we're actually not just syncing pods and services, we're also syncing ingresses, which allows you to use the underlying host cluster's ingress controller, which is pretty cool because not everybody needs to maintain their own ingress controller, right? Because that's something, consumes a load balancer, which costs money, and it's kind of such a basic thing to, have a load balancer. So the ingress should live in your V cluster because that's something application specific, but your ingress controller should really live in the host cluster. So you can tell the syncer, please sync ingresses. You can also theoretically sync CRDs and other things, but that would require that both your V cluster and your host cluster at least have a common understanding of what that resource means. That means if that CRD is not available in your host cluster, obviously it's not going to work. If the host cluster has a lower version than your V cluster does, it's also not going to work. That's why by default, we're just syncing very basic resources, like pod and service, and then also ingress is enabled by default. But you can also disable anything and, sync config maps and secrets if you need that, right? There's a lot of things that you can, configure with the syncer to kind of customize the experience, either per V cluster, or you can also essentially create templates of these V clusters for your users, and then, enforce it on different levels of Kiosk, for example.
You mentioned supporting different versions of like the API server. What happens when the host cluster is on an older version? Like, can you mutate a pod to downgrade it, or? Yeah,
very good question. So typically, yeah, the basic resources that we're syncing don't change a lot, right? So pod spec or services, they don't change a lot, especially not stuff that the users are actually frequently using. But yeah, if there is, I mean, with Ingress, we kind of have that change coming up, right, in 122, where, you know, API, the kind of the better groups get dropped. I think Ingress is affected by that as well. Yeah, then you essentially may have an issue if the vCluster already has a newer version, the host cluster doesn't know it, right? That is creating issues. But it's very limited. It has a very limited impact. And typically you'd recommend to keep the host cluster fairly updated to prevent these issues. That is essentially the solution to that problem. But yeah, that is definitely something to look out for.
Well, I think that's, we could keep on going, but I think it's probably time to stop. Lucas and Rich, really appreciate your presenting today. I think you really got a lot of us thinking about different things, a lot to absorb and a lot to look at. So I'm assuming you have a Slack channel or group?
Yeah, yes, you can go to slack.loft.sh, or I think it's linked from pretty much any of the open source projects that we have. So if you go to vcluster.com, you'll find the link there as well. Yeah, happy to chat in greater detail, or if anyone has questions or finds a bug, you know, reach out anytime. It was a pleasure, you know, talking about the different projects with you, and it was a pretty fun session. I didn't expect the questions to be that intense, but it was always fun to go so deep. Yeah.
Well, we also there's also a Devspace channel in the Kubernetes Slack.
Okay. Oh, yes. So I think several of us are going to be looking at that as well. So, well, thank you again, Lucas and Rich, and again, if you're ever out here and want to go skiing in the winter, let us know. We'll host you.
Yeah, sounds great. And if anyone's at KubeCon, if it happens in person, we'll see how the Delta variant is, you know, spreading or not. But if it happens in person, we're going to be there, and, you know, happy to catch up with anybody.
Sounds good. I'll be there. Thank you again.
Thank you.
Bye.